Shadows and polarization. Here are your priming questions. Shadows. This is pretty easy to start with. These are formed where light rays cannot reach. Now there are two main parts of a shadow. We have the umbra, which is going to be the total shadow, and then we have the penumbra, which is the partial shadow. So if you think of eclipses, there are a couple of different types of eclipses. One where the moon basically goes away, and there's one where the moon shadows part of the earth. And so, for example, if the moon is over here, somewhere in this region, this is the umbra, you completely cannot see the moon. Now, if the moon is somewhere over here, the moon you can still see, it's just much more dim. And so we have the umbra, which is the total shadow, which you can see with these light rays, as we showed those there. And we have the penumbra, the partial shadow. And if you think of the regular type of eclipse, where we have the moon shadowing part of the earth, you have the total eclipse, which is the umbra, and you have a partial eclipse, which is in the penumbra. Now, temperature can also cause light to bend. And so in this case, when we have a shadow due to temperature, it's because light is refracting. That's important. Light is refracting and moving away from something, so the light rays aren't touching there, which allows you to be able to see convection currents through the air or even through liquids. And so this is the reason why stars twinkle at night. This is also, if you look at the ground when you open up your car, if it's been sitting in the sun, you can see convection currents. You can see the heat escaping from the car. And also, sometimes if it's hot enough, you can even see the heat waves as they're radiating from the hood of your car even. If you look carefully, you can see the waviness of the air, it appears. And so that is due to the change in temperature bending the light, causing refraction. And so this is what some of it looks like. So if you have a light source, you can look through it and you can see some of these different examples. This is also the reason for mirages. And so a mirage is actually a reflection, or it appears to be a reflection, but it is actually a refraction of light. And so in this case, the light is coming down from somewhere far away, and because of the temperature change, it causes the light to bend to your eyes. So that is what causes these mirages. Now, polarization. Light from the sun comes in all directions. It is unpolarized. So if I were to draw a circle, that means that the light is coming in all of these different directions, and you can't tell any of this with your eyes by itself. Okay. Now, what a polarized filter does is it aligns the vibrations of the wave by filtering out the waves of other directions. The way to think about it is transparent in only one direction. So if we look back over here at the unpolarized light, if we had a vertical filter, for example, only the vertical light would be able to pass through, and so all of the light at that point after a polarized filter will be aligned vertically. None of it would be horizontal or even diagonally. And what this polarizing filter does is it is opaque to the other vibrations of light, and it can actually realign some that are at an angle. Okay. Now, what's interesting here is most reflected light is polarized. You can't tell this with your eyes by themselves. You need to have a polarized filter over your eyes to be able to even tell if something is polarized. And we'll go through some examples and some demos in class. So here's another example. So if you think of a polarizing filter like the picket fence, if you have light that is vertical, then it can go through the picket fence and you can see it just fine because it's transparent to the vertical light. On the other hand, if the light is oriented horizontally, no light will be able to pass through. It's completely opaque to light that is 90 degrees from the polarizing filter. And so this has many different uses, and for us, when you go from unpolarized light to polarized light using a single filter, it automatically cuts the amount of light going through by 50%, and that's on a single pass. If you have two polarizing filters and rotate them, you can see what can happen. You can reduce this all the way down from 50% down to 0% to where no light is going through. And I'll show you an example of that in class as well. Now, one example, I want you to think about some other examples of this, is 3D viewing. So in this case, if you have your right eye or right lens for your right eye being polarized horizontally and for your left eye being polarized vertically, if you look at a video or a movie that is designed to be viewed in 3D, you'll see if you don't have these special glasses on, you'll see all of the light and it won't make any sense to you. But once you put these glasses on, it filters the light going into each eye, and once that happens, your brain will compile it together into a 3D image. It's not exactly that your eyes see, per se, it's your brain that takes in the data from your eyes that formulates the image that your brain sees. So here are your priming questions again. We'll do a lot more discussion in class along with some demos.